I apologize if my webcam is focusing and unfocusing. We'll do the best we can. Let's look at geographic range. Geographic range. What geographic range is the theoretical distance you should be able to see an object from, considering the curvature of the Earth and not the visibility. So just considering the curvature of the Earth. If you are so high, you should be able to see a certain distance to the horizon. And if you're looking for an object on the other side of the horizon, and it is a certain height, it has a certain distance that it can be seen from. So let's look at that. Here's the curvature of the Earth. Right? Here's the horizon. Here's the height of your eye. Here is the height of the object you're trying to observe. If your eye height is this tall, you have a certain distance you can see to the horizon. And if the object is this tall, it has a certain distance that it can be seen from. Right? Here's a distance. Here's a distance. So what we're looking for is, we're going to use a table. Let me show you the table. And it's going to tell you, if you're this high, you see this far to the horizon. If your object is this high, it can be seen this far from the horizon. So let's look at that table. Okay, this table, sorry about my webcam again. This table is distances to the horizon. And I'll read a problem here. First problem says, what's the geographic range of a light that is 25 feet tall and your height of eye is 30 feet? So what you do is you look for, again, we just need the height of your eye and the height of the observer. Or, excuse me, the height of your eye and the height of the object. So the height of the object here is 25 feet. So here is height in feet, right? We find 25 is right at the bottom, and it yields 5.9 nautical miles to the horizon. So we'll keep track of that, 5.9. At 25 feet tall, you can see 5.9 miles to the horizon. And then it says the height of your eye is 30 feet. So we find 30 feet on here, right here. See? Height in feet. 30 feet. And it yields 6.4. Sometimes you'll get problems that are in between. Over here it starts jumping from like 125 to 130 to 135 to 140. So sometimes you have to split the difference. Or you can use this, the formula to calculate distance to the horizon. DH equals 1.17 times the square root of the height. But if you don't want to worry about that, then don't. If you like numbers, you can use this to get exact numbers here. But you can just estimate them just as well. So again, let's look at it one more time. The problem says, what is the geographic range of a light that is 25 feet tall and your height of eye is 30 feet? So we go to 25, it yields 5.9. We go to 30 feet right here, and it yields 6.4. So let's take a look at that on the board. The other board. Okay, so this problem says that, again remember, two things, the height of eye and the height of the object. So this problem says, what's the geographic range of a light that's 25 feet tall? So the height of the object is equal to 25 feet tall, which from the table we looked at yielded 5.9 nautical miles. And then the other thing is the height of your eye. How high is your eye when you're on your ship, when you're on your porch, anything? How high are you when you're looking towards the horizon? And our height of eye was 30 feet, right? Maybe we were on the bridge of a, 60 foot or something. And that yielded, from our table again, 6.4 nautical miles. 6.4 nautical miles. Now we add those together, right? 3, here the 1, 12.3 nautical miles. That's one of the answers here. It's D, 12.3 nautical miles. So that's how we're going to do a geographic range problem. And just to sum it up again, it is the height of your eye and the height of the object and their distances to the horizon. Then we add those two distances together. So the height of our object in this case was 25 feet tall, which from our table yielded 5.9 nautical miles. The height of our eye was 30 feet, which yielded 6.4 nautical miles to the horizon. We added those up to 12.3 nautical miles to the horizon, and that's the geographic range, the theoretical distance we could see something over the horizon. You're going to be hard-pressed to see something from 12.3 miles. But maybe you could think of it in terms of VHF communication. If somebody's antenna is this high, if your antenna is this high and someone else's antenna is this high, you should have a direct line to that antenna at this distance. That's how I like to look at it. And that table that I showed you earlier, the distances to the horizon table, is one of the PDFs. You can download that PDF from the course. It's right there. It says distances to the horizon PDF. You can print that off and do all of these problems, these geographic range problems. Any questions, put it in the forum or email it to me and we'll get those answered.